All right, I'm going to go over now what arithmetic sequences are. So we're going to focus first on arithmetic sequences, and then later on in the unit, we're going to go over geometric sequences. So here are some examples of three arithmetic sequences. So they're pretty much the most simplest, or they're pretty much the sequences that you can recognize pretty easily because all you're doing is adding the same number every time. So here we're always adding 2. We go from 2 to 4 to 6 to 8 to 10. And we call this number that we're adding our common difference. We use lowercase d. It's a very terrible, poorly drawn rectangle or box. I can't live with myself. Let me do that again. Call this common difference d. And so the common difference for this first sequence is 2. Now for the next one, here we have 29 to 25 to 21 to 17 to 13. So we're going down by 4. So our common difference is -4. And for this third one, we go from 3.5 to 2 to 0.5 to -1 to -2.5. And so we're going down by 1.5. And so our common difference is -1.5. So it doesn't matter if our common difference is negative or positive. Um, we can think of it as adding a positive or adding a negative or subtracting a positive. Just don't get too hung up on that. But for um, like textbooks and stuff, they're pretty much always talking about adding because you can add a positive number, you can add a negative number. Um, anyway, so let's look at now how we can find terms when you're given an arithmetic sequence, and you have to find let's in this example we're going to find the 10th term and the 115th term when we're given the first 5 terms. So for this, we're going to refer to these two equations. This first equation here is going to allow you to find any term, so any an term, so that we can find the nth term from using the common difference and the n and another term. So we say that the nth term is equal to the nth term plus d times n minus m. And I'm going to explain what all this notation means. It's really simple. And if you look, the common difference is just going to be equal to an minus am over n minus m. But both of these are just the same equations. This is just rearranged for the common difference d, and this is solved for the an term. But let's go ahead, let's do an example because I know hopefully I haven't confused you and lost you here yet. So for example, let's look at this sequence. We want to find the 10th term, so we want to find A10. And we also want to find A115, but first let's find A10. Let's put A115 down here. So the first thing I recommend is to figure out what the common difference is. And you just have to look to see what you're adding each time. In this case, we're adding -7, or you can say you're subtracting 7, or we're going down by 7 each time. So then our common difference is going to be -7. Now we have our an term, which is 10, or A10, and let's write out that n is 10, because that's what the subscript 10 here is. And then we need to pick an an term. And you can pick any one of these, because remember that this is A1, this is A2, this is A3, this is A4, This is A5. You can pick A1, A2, A3, A4, A5. It doesn't matter. Just pick one. So let's just pick A1 because it's probably the instinct. So we're going to say A1. And then let's add plus our common difference, so plus -7 times n minus m. N we established is 10. And m is going to be 1 in this case because we chose A1. And so our subscript m is 1. Let's write m is 1. So that means we're going to do 10 minus 1. Then from here, you can just basically solve. Let's just rewrite this with A1 because that's 46 because that's what it is. So we set this equal to 46 minus 7 times 9. So 46 minus 63. And that'll give us -17. Now, of course, you can just always brute force it, meaning you could just keep on subtracting 7 until you get to the 10th term. But if you're going to find the 115th term, you're not going to want to do that because you're going to have to do that 110 more times. So let's look at this example now. If we want to find the 115th term in this sequence, we again pick A115. That's our AN. So that means N is 115. And we need to find an AM. Now, last time we picked AM to be A1, but it doesn't have to be A1. We can make it A1 again, but let's make it A1 again because in the next example, let me show you a different way. But let's just say we make it A1 again. It could be the same one. It's completely fine because then that's going to mean that M is 1. Then here, just make sure we go about this the same. The common difference is the same, -7. But we're going to have N minus M inside the parentheses, or 115 minus 1. And we just work it out. So A1, 46 again. I didn't mean for it to be so crooked. 46 minus 7 times 114. 46 minus 700, 770, minus 798, right? I don't want my calculator to get bored, so let me go ahead and let me have him do something. So 798, so 46 minus 798. Yeah, and we would get -752. That glares in the way. Sorry about that. Wait. -752 is what that says. Okay, the first example is always a little tricky, especially as I'm still working on this teaching. So let's go through another example. Let's see if we can flow through it much better. So it's still going to find the 10th and the 115th term. And let's look at the example. B, what we got? -10, -4, 2, 8, and 14. All right. Okay, so let's find A10 first. A10. So we need our common difference. So this sequence is going up by 6 each time. So our common difference, D, is equal to 6. AN, let's pick an AM. So remember, we have A1, A2, A3, A4, A5. And let's just pick A3, just because, just so we can use a different number other than A1. Let's pick A3 plus 6 times n minus m. So our n in this case is 10, and our m in this case is 3. So then we're gonna have 10 minus 3 here. A3 is 2, so we go 2 plus 6 times 7, 2 plus 42, and we'll get 44. All right, cool. Now A115. Now let's see if you maybe try to give this one a shot on your own. So pause the video and see if you're catching on. Let's try to find A115. While you're doing that, I'm going to grab some much needed water. Old school. All right, so A115. Let's go ahead. Let's stick with our A3 plus our common difference D. N minus M. In this case, our N is 115. Our M is 3. So we're going to have 115 minus 3. A3 again is just going to be 2. So we're going to have 2 plus 6 times 112. Which will be 2 plus 672, right? Now give us 674. All right. Simple. Now, if you're wondering, like, what's going on? How does this formula work? Well, let's think about this example. If we're trying to find the 115th term, and we know the first 5, we know it's growing by 6 each time. So if we are going from A1, what that means is we're going to have to add 114 more times to A1. In this case, though, we started with A3. We started with 2. And if we're going to get to 115, we're going to need to add 112 more times to 2. That's where this plays a role. You see, for this example, we had A3 plus 6 times 7 because the 10th term is only 7 ahead of the 3rd term. Let's start thinking about that, and let's go through one more example like these. Because once you catch on to like the logic and the concept, this stuff is actually pretty easy. It's pretty much like linear equations that you learned in algebra. But what really confuses students is just the notation. So for C, we have 15, 14.6, 14.2, 13.8, 13.4. Whoa, whoa, whoa. I don't actually know what that one. Oh, here we go. So maybe give this one a shot. Try to find the 10th term and the 115th term. But here I go. Let's start off the common difference. we're going down by 0.4 each time. So our common difference D is negative 0.4. So A10, let's go with A1 plus a negative 0.4 times n minus m. In this case, n is 10 and m is 1. Now, a side note, you may see this usually written in a lot of textbooks as an is a1 plus d times n minus 1. You probably maybe see this equation. It's the same equation, it's just they're always telling you to use a1. The reason I like writing like this is so that you don't have to feel like you have to always know the first term, because maybe you're going to get problems where you don't know a1, and you may waste your time trying to solve for a1. But if you know that you can use any other term, you won't waste your time. But you can still use a1. So let's just work this one through. So a1 in this case is 15 minus 0.4 times 9. 15 minus 3.6. Now it'll be 11.4. All right. And now A115. So if we again decide to use A1 plus, negative 0.4, and I could put minus 0.4, but I just like writing, the plus and minus sign, and they're really cool. And in this case is 115. M is 1 in this case. So we're going to take 115 minus 1 in here. And we're going to get 15 minus 0.4 times 114. And recycling, let's go. Let's move down here. So again, I apologize about the glare. I have a low budget cost. So we get 15 minus 0.4 times 114. Let me get my calculator. It was getting bored, so let me go ahead and let's use it. So minus 45.6. Let me get negative 30.6 as our 115th term. Nice. See, so then again, here's the logic. If we want to find the 115th term and we start with A1, then what we're going to do is go down 0.4, take away 0.4 114 times. That's what's going on here. That's what this formula is saying. We're starting at A1 or 15, and we're going to take away 0.4 114 times to get to the 115th term.